Hi, good evening. Welcome to the second session of the automotive product design using acoustics material. This is Satish from Leameng Solutions, and I would highly recommend the viewers to watch the part one session of this particular topic, where you are bound to get and prerequisites specifically for the mechanical engineering students who wants to pursue their career into the product design. So on the part one session, we have elaborated about what all are the prerequisites or skill sets which are quite mandate for a mechanical engineer if he wants to further enhance his career into this specific area of interest. So let us continue with the part two session today. And to just reiterate what we had discussed onto the part one, this is the slide where we had last ended up. So the acoustics is something that it's a subject of vibration which propagates and wave through a different source of mediums or transmissions like solid, liquid, or gases. And we all know that the sounds propagates or moves faster on solid when compared to a gas or liquid. So a sound is also a mechanical wave which is in motion, which carries an energy from one point to another point through a source of medium. So here what exactly you need to understand is you need to understand about the different sources of energy or different sources of sound when it comes together, and when you're driving a vehicle, that could be an electric vehicle or an IC engine vehicle. You being a driver or you being an passenger, you are bound to hear a lot of different noise sources. And what is the situation on which you would be? That is what is all about this topic of acoustics, specifically when you're going to be a product designer. Okay. So this particular photograph, what you see here is the human auditory field, which is from 20 hertz to 20 kilohertz or 20,000 hertz. So this is the frequency at which a human beings can hear the noise, and it's being compared with different species and animals to what is their capability of hearing to the different sound sources. So let us have a look at the slide which talks about the different source noises. Like we have the the pass by or the pedestrian noises, which would probably get inside the cabin compartment through the doors or windows, which is so called as the exterior noises. And there are noises which could probably come in from the engine or from the diesel engine of an air intake manifold, and these are all some of an airborne noises which could get into an cabin compartment. And similarly, from your sunroof, you could witness an buffeting noise, which is an air noise getting onto the cabin. And similarly, you do have an rattling noise or booming noise, which is primarily because of the powertrain noises which is being witnessed. And the tire noises could also get generated because of the friction between the tire and the road, or the profile of the thread on your tire, and the suspensions, which is a part of your vehicle architecture. These are the three elements which constitutes for witnessing a tire noise. Similarly, for an exhaust noise, also you bound to get, because if you look at the current time of BS6, you are bound to have many catalysts being installed through your exhaust line. It starts from your diesel oxidation catalyst and to the NOx catalyst, where you try to fumigate or where you try to kill the particulate matter or the NOx elements, which could probably come from the source of diesel engines or from the diesel fuel. Okay, so these are some of the different noise sources which are bound to witness when you drive a vehicle at a certain velocity. And on your right side image, it summarizes the different source of noises which could generate due to the powertrain, exhaust system, brake system, road and tires, and finally wind. And these are being mitigated by using a mount, suspensions, and air, which could lead to an vibration noise, which is so called as the BSR or the bus squeak and rattle, and which could lead to an ride comfort or a quality control. So what exactly you need to do is that being a product engineer, so if you have been assigned an development of an interior component, be it a dashboard or a floor panel or door panels or seating systems, or if you have a look at your exterior systems like your spoilers or tailgates, bumpers, there is a large window where you can always try to think about the acoustics subject through the aerodynamic study. That is one way of trying to understand about how you're going to finalize the class A surface, and also by considering the cooling parameters of your engine or your EV battery. And there are some instruments where you can validate for the acoustics materials being used or being employed to dampen the sound intensity level or the sound pressure level or the transmission loss, which could probably get arised for witnessing of huge sound noises. So here you see that there are the different materials like the poroelastic materials, which are made of melamine on polyurethane materials, and you find such blocks majorly onto the door panels where you're bound to have a door slam and you need to reduce the slamming noise coming inside the cabin compartment. Similarly, you classify the different materials like felt, aluminiums. The felts are being used especially for your carpets and for your headliners, and this not only helps to reduce the noise but also insulates the heat from getting inside the cabin compartment from the exterior temperatures. If you look at these polyethylene films or the aluminiums, they have been highly employed for the tailgate inner panel where they try to reduce the structure borne noises. So the noises are being classified into an airborne noises and structure borne noises. So the airborne noises, which are something which comes from an external and you need to pursue and you need to do a proper vehicle level of validation. That could be through a simulation by using an restrictive LMS software, or you can also do it on a vehicle level by using an analytics chambers. So these are the different ways and by which you try to understand about in which area or which system or subsystem or component level you need to go and you need to control the noise. On your right side, you could see there's the different properties of an acoustics material, which has a porosity, the airflow relativity, tortuosity, characteristic length, density of fibers, materials, Young's modulus, Poisson's ratio, and finally the loss factors. These are some of the properties which put together to form a complete acoustics subject materials. So we will find on some of its ratings through the validation from the upcoming slides. So here you see that the usages of different acoustics components on an IC engine vehicle, which starts with your lightweight dash insulators. You have for the molded headliners, for the bonnet application for insulating the heat. Similarly for the carpets and wheel liners. So these are all some of the equipments or some of the elements which has come into the picture based on a simulation validation or by using a real-time vehicle validation. So these are the only two ways by which you can interpret the noise sources and how you can try to dampen the noises. So you can do it for any new materials or a new formulation of a material by doing an experimental process or by using a simulation process, or you will have to physically do a validation on a physical component in a vehicle level so as to understand about in which area what is the noise factors. That is how you try to do it. So similarly, if you look at an electric vehicle, so I don't want to just read out the names of the different applications being used here. So you do have a similar sort of and requirement of acoustic subject, even though the powertrain is completely different. Like you use a battery and an induction motor to propel an EV vehicle, but still there is a noise which is getting generated, and that is what you see over this particular slide about the different NVH or the noise vibration and harshness challenges which you face between an EV vehicle and a IC engine vehicle. You could see here that the road noise which is being witnessed on an EV vehicle is more by 10% when compared to an IC engine vehicle. Similarly, the wind noise is also generated two folds than an IC engine vehicle. But the powertrain noise, you can see that it has been drastically reduced. So what is that which has generated more noise for the road noise and the wind noise? When you look at the powertrain noise is being reduced. But you can see here that the auxiliary systems are almost nearly the same. There is no much of an variation. So these are the things which can be controlled by using a structure bound noise. This could be something of an structure bound noises which are trying to use an application of acoustics topic where you're trying to dampen the noise. But here when you see that the powertrain noise has been significantly reduced from 50% to 15%, that means that there is a scope for the passenger or for a driver who is inside the cabin compartment to hear a lot more of other noises which are not to be heard in the IC engine vehicle because of the huge noise coming from the engine or from the gearbox. That is why you are witnessing less of road noise and the wind noise, whereas on an EV vehicle, since your powertrain loss is very low, you are witnessing more of road noise and wind noise. So to summarize, in this particular slide, you see that the requirement of acoustics or an acoustics engineer or an expert is also important going forward for developing an EV car or a vehicle. So you need to think about these different applications. You need to think about from material point of view, or you may have to think from the properties point of view about how you need to balance the right blend of different properties so as to meet the required sound intensity level and the sound pressure level being getting transmitted inside the cabin compartment through the different sound absorbing materials. So this is what something which you will learn much more once you get enrolled to our certificate program in product design using acoustics. You are bound to learn much more of things, and you will be also given some exercises, some assignments whereby you do and perform and validate about how you can significantly try to reduce the noise getting onto the cabin compartment. So what is the whole logic? Or what is the reason behind doing this entire exercise for acoustics? Why do you spend a lot of money and time and doing packaging study on a vehicle level to make sure that you fit different type of materials, different type of felts, forms? What is the whole logic behind is, or what is the effect of not having it? Is that you get into an human comfort, and if the human is not getting comfort and if it's getting an very momentum or a regular sort of a sound which is being heard, that could lead to an accident situation. So if you would have done a DFMA review specifically for an acoustics point of view, and you being a product engineer or a product designer, you are bound to do a DFMA review with the cross functional team and with the customer, and you can yourself understand what exactly will happen in terms of your severity rating by considering your occurrence and the detections, and finally these RPN number, like which is a product of all these three numbers. But the severity rating would be much higher, that could lead to a non-conformity of the vehicle to get launched onto the road. So these are the three different parameters for the effect of noise coming to the comfort and perceptions, the safety, and finally the health concerns which could probably get arised because of the continuous hearing of an abnormal noise. So this is one of the reasons why you should always think about having a pleasant driving. So when you drive and local a vehicle with an international vehicle, you could probably try to understand about what is the difference between these two different levels of vehicles. So you could see here on bottom there's a scale rating which talks about decibels, which starts with your 10 decibels for a leaf falling off from a tree till 160 decibels for a fighter jet or sonic jet. So this is how you try to really understand about the or the sound which could probably get arised, and that could lead to a different health related issues. So when you talk about this health related issues, this is not something like a person once he gets off the vehicle he gets into this situation. It is that Once he's continuously hearing the noise when he's driving inside the cabin or when he's driving a vehicle for a long distance and the sound is not getting reduced, then he's bound to get into all these issues. So we have some of the design solutions currently in place for some of the applications. For example, for your tailgate, if you have to control your structure borne noises, we employ the aluminum or polyethylene film so that it also reduces the noise and also the thermal insulations. Similarly, for the dash panel, where you have a sandwich of your heavy layer plus a foam or fiber which is being attached to the steel plate. So this also helps you to control to a large extent the booming noise getting inside the cabin compartment. Also it insulates the heat from not entering inside the cabin compartment. So it is having a two purpose. That is why you give a lot more of importance, or the NVH and durability engineer gives a lot more of importance in designing or in concluding on what type of material that you need to give. So coming back to this topic of a product engineer, you need to really understand about how you will have to make use of it. For example, you might be an engineer for floor console or for a dash panel or for a door panel, and you may need to protect the class A surface at an initial concept level for a packaging of the acoustics material. That is as simple as that. You may have to do the packaging layout and you need to understand about what should be the distance, what should be the thickness, so that your final 3D, or before you start getting onto the master sectioning and start developing the 3D designing of any products for an interior for exterior component, you being a product engineer, you need to understand at what all places you need to employ these sound dampening systems or the applications. Accordingly, you need to have the packaging study done properly. So similarly, you have for the floor panel or for the carpets which are being employed so as to reduce the road noise or the tire noise being resonated inside the cabin compartment. Similarly, for the bonnet application, you have a felt or an application where it try to insulate the heat from not getting inside the that engine compartment. So here this is the slide which I was talking about how you are going to validate from a material level. You have got lot many of material and its combinations, and we do the noise validations in two phases, that is on a vehicle level or on a component level, which you are developing from a third party or through a supplier. So usually the design engineers who are employed on tier 1 companies, they don't much understand about these materials nor it is really required, because the tier 2 or the dedicated suppliers, they bound to have all this detailed information about what it takes to develop the right application as per the OEM's requirements for reducing the noise or for insulating the heat. So this is a graph which talks about the sound absorption coefficient values on your Y scale, and on your X scale it talks about the frequency at what it is trying to move about. So it just gives you an example of an experimental and for a simulation between the two plots, which you can see, that is for the aluminum foil and for the cotton shoddy materials. So similarly on your sandwich component for film shrimp, so this nitrile rubbers and films, you usually find it for most of your interior components, such as your dashboard, where it insulates between the ducts and the air vents to not have any air leakages. You would always go for this nitrile rubbers. And sometimes you also use this so as to dampen the noise. Okay, if somebody tries to hit their dashboard on the air surface, you would bound to hear a lot of vacuum noise coming from the B side. To have a less intensity of the noise, you try to fix a pad made of a nitrile rubber, which would try to reduce the noise coming out of it. So this too has the same sort of a graph which talks about the frequency and the sound absorption coefficient, and you can see here that the experimental and the simulation results are nearly the same. They don't have much of a difference. And this is what I was talking about, the different properties of the material or the characteristics which has to be taken care once you start developing any component. Each of these parameters has got its own unique importance when you start developing. So as a product engineer, you don't need to go to that level of understanding, because this is more to the tier 2 supplier who is developing, who is validating from his friend. But from a product engineer, the best what you can do is that you can at least try to do some benchmarking or in research to find out about what best can be done to mitigate the issues. And to just give you a heads up that going forward, especially for an electric vehicle platform, the job employment requirements for NVH engineers or the NVH durability engineers is going to increase, because as I said, there's a road noise and the pass by noises are getting increased because of the reduced powertrain noise on an EV vehicle. So the demand for sound engineers or for NVH engineers is going to ever evolve for the upcoming times. So you just need to get yourself equipped with the right skill sets, product knowledge, and you can confidently try to crack the technical interview once you go for any technical sort of an interview. So 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 it is all up to you now, and you need to look at yourself to know about what exact skill sets gap that you have. And if you feel that you are need to upskill your requirement, then you feel free to come back to us for a counseling, and we can help you out in selecting the right program based on your career requirements. So here's a roadmap which we have developed based on my last 2 decades of experience onto the industries, and this is what I could brief into this one single slide, that currently you are in this position where you have an basic knowledge of CAD plus the engineering subject knowledge, but this will not be sufficient once you have to go for any technical interview. So you need to acquire domain knowledge and the product knowledge through a very systematic methodological, and there are certain set of principles and rules which are being underlaid and which are quite mandate for a product engineer to understand and to know about how an OEM or a tier 1 supplier works in developing a product design. So, and finally, the last but not the least, yes, what one side you have a technical capabilities. At the same time, you also need to nurture your soft skills. The soft skills can be for the verbal and for your written. You also need to have a good presentation skills so that you are able to crisp the informations for the customers at the right times. And the only request what I have for the young engineering graduates who are passing out from college is that I mostly find this sort of an resume on your left side. This is got has so this only tells that this particular person he doesn't have any vision. He does not have any vision on his career. He just listed down whatever he has on his hand currently, and he doesn't have any future scope, nor he has any vision or mission of what exactly he wants in the next 5 years of time. But here on your right side, you could see that a person who has got trained, not necessarily from me, from any other organization, where he's getting an opportunity to upskill himself so as to meet to the directives or to meet to its objectives. So he needs to mention his resume in such a way that it is being attention, or an employer or a person who is screening his resume for the interview gets screened to understand about, yes, that this is the right guy who is looking for a right job. So it makes a lot of sense to qualify for an interview rather than looking at this resume. It doesn't show anything, or it doesn't show any reflection of its commitments towards the job for which he has applied. So we showcase some of the internship students who have joined us and who have enrolled with us for a program plus a mini project plus 4 months of internship. And this is what they do, and the people talk about us, or the students talk about us. That is a pride moment for us. And we also have a list of, and this is just a glimpse of 4 candidates, but we have got almost around 9 consequent running internship candidates with us. So they work in lightweighting areas. Some of them work for the crash worthiness. There are few guys who work for the pedestrian safety, for the human safety criteria. And we recently started taking interns for the acoustics platform as well. So why is the reason that you have to come to us for getting a solution is that the whole program content or the upskilling contents are very much in line with the current OEM standards or with the tier 1 design methodological standards, so that you get a real hands-on experience, and that's what gives you a confidence once you go for an interview. And the industry expert is me myself, and I'll be able to deliver you a content for 9 different programs. And you can go through our LinkedIn or our home page to find out about the different programs onto which myself and we have a panel of experts who would give their commitment to you once you start enrolling to our programs. And we are technically oriented, and we also have lab sessions supported as a part of our curriculum, where we stand by and we provide you different ways and means and methods by which you try to acquire your domain knowledge. So that is the ultimate goal of you having enrolled with us. So thank you for your time, and if you have any questions based on this particular topic of certificate program in automotive product design using acoustics material, feel free to reach me at this contact number 99755 and I have my email ID, and the list of credentials are being mentioned here. So let us meet up shortly for the new classes. Until then, take care. Bye.